Hi everyone, I am the founder of the Grey Blind Owl. Today we will learn how to do dynamic memory allocation. After laying the proper foundation for this topic in this lecture, next week I will explain how we can relate what we have learned today to functions for matrices. Dynamic memory allocation is a very important issue for the C programming language. In all the programs we have created so far, we have determined the limit values we need ourselves. Although this situation does not cause any memory problem or a further speed problem for us, this method we use is quite wrong. If we have not encountered a problem until today, it is because the codes we wrote were at a very basic level and were not capable of challenging the machines we use by today's standards. Except for the project we will do at the end of our training series, dynamic memory allocation has not been and will not be critically necessary in any code that will be written in this series. However, if we want to create a good and optimized program, we must learn this subject truly and integrate it into every program we write from now on. Well, what exactly is this dynamic memory allocation? Dynamic memory allocation is a very useful memory control method that creates an active link between the user and the program and allows us to efficiently evaluate the computer memory in line with the user's needs. Take, for example, the phase of creating an array. Normally, we set a number as a limit, considering that a user will not enter more elements than this limit within the scope of the program. If we assume that this limit value is 50 and that the number of elements we receive from the user is limited to 6, we can see that for the 4 element space is wasted for this array with a simple calculation. Again, in the opposite case, when the user needs to overdose, for example, if he or she wants to enter 70 elements for an array, our program will not be able to provide a proper service to this user. However, dynamic memory allocation eliminates all this problem and prevents no more or less assignment than the amount the user needs. For this reason, knowing dynamic memory allocation should be seen as a necessity, not an option. We include our libraries. We will also use stdlib.h for the dynamic memory allocation ready-to-use functions. Dynamic memory allocation ready-to-use functions. Hashtag include stdio.h. Hashtag include stdlib.h for the dynamic memory allocation ready-to-use functions. I will explain these functions below. Okay, we create our prototypes here. Also, I will explain these prototypes below. We create our main function, integer main, the brackets and the curly brackets. If we want to make dynamic memory allocation, we must first define our array or matrices as an address holder, as a pointer actually. Like that, integer pointer student grade array first and pointer student grade array second, and the semicolon. Because memory management is directly related to addresses, and what we need to do in the first place is to keep the address in mind. Since we need two arrays in our program, I will define both of them this way, like that. Now, I create three integer variables, I for counter, limit for element number, and addition for extra element number. Integer I, limit, addition, and semicolon. I create a float variable for overall of the grades that are entered by the user, float, overall, and semicolon. Okay, now we will get the student number that the user will enter their grades. Printf, please enter the student number that you will enter their grades. Scanf, the person's ID, ampersand, limit, and semicolon. Now, with this information, we can now do dynamic memory allocation. At the point of allocation, we will meet two new functions. The first of these will be malloc and the second will be calloc. And Although both functions seem to do the same job, at the end of the day, they actually have slight differences. This is important. They have actually slight differences. Malloc does not pre-initiate, that is reset, so it may contain garbage values, but calloc takes these into account when allocating space and performs the reset process inside. But malloc is quite fast compared to calloc function since it does not perform the initialization phase. So malloc is quite fast compared to calloc for this reason. Does not perform initialization phase. In the final analysis, both are quite convenient to use, and these differences I have mentioned are quite insignificant in general operation. Now, if we use calloc to open space for our array name here, we define here, for example, this one integer pointer student grade array first, only the name part, array name, and variable type pointer because we use the addresses, and calloc function limit value our limit value we get it here printf please enter the student number that you will enter their grades. This is our limit value. This is our border for our array. Okay, and size of variable type and semicolon. For our array, student grade array first, this is our array's name, and this is equal to integer pointer. Our variable type is an integer, and we use a reference with the type and integer pointer. Calloc our function, and our limit value limit, and size of variable type. Our variable type is integer, as I said before, size of integer and semicolon. Okay. Thus, we open space which is equal to limit times the size of our variable type. Also, with this way, we put this empty set of addresses inside our address holder and make it an array. After this process, our array will be our address holder will be an array. Okay, if we use malloc to open space for our array name, variable type, and reference, so for example integer pointer like that, and malloc limit value and limit value times size of variable type, like that. Student grade array first, our array's name, our address holder name actually, and this is equal to integer pointer malloc limit times size of integer and semicolon. Again, we put this empty set of addresses here inside our address holder, and we make it, and then we make this address holder an array with this operation. Okay, they are the same actually, but they have some differences. We learned how to use the malloc and calloc functions. However, since the allocation process can be adapted to more than one array, we want such a common operation to be done in a function so that it is not repeatedly coded. Okay, we will turn these operation a function here, like that, open space, and we allocate that here, not in the main function, because we will do this operation repeatedly, and we do not want to write these codes after and after. Okay, and the main point to note here is that our function returns an address. Because these operation returns us these function actually returns us an address, and we put it here. This is our array, this is our address holder, and we put these set of addresses into this address holder, and our function returns an address. We use integer pointer type for our function. This is why we use variable type and reference. Okay. Okay. Now, since the only information required to allocate space is the limit value, we only share this information with our function. Here, student grade array first. This is an address holder, so we returns an address again here. We returns a set of addresses into this variable. Open space, limit, and semicolon. We go to the open space. This is our space allocation function, open space function. Integer pointer, open space, our function name, and integer limit. Our function returns a set of addresses, so we use variable type and reference in this part. We create a temporary address holder for our array, integer pointer, allocated array, and semicolon. We allocate a convenient space for our array, and we put the empty set of addresses inside our temporary address holder. Here, allocated array is equal to integer pointer malloc limit times size of integer and semicolon. Now our allocated array has a set of addresses here. We returns the space to our main function. That is why we use integer pointer for our function type. As I said before, return allocated array and semicolon. Now here, student grade array first. This is an array now. And its border is equal to the limit value. Okay, we have successfully allocated space for our array. Now we can use our array, which we defined as an address holder, as a normal array from now on. Now, we want the user to enter the grades of the students with this function. However, we consider that we use the dynamic memory allocation, so maybe our limit value will be changed by the user. Okay, maybe our limit value will be changed by the user. For these, we need our grade array, an initial value, and a number that determines the limit value. Okay, get the grades, our new function. Student grade array first, 0 for initial value and limit for a number. Okay, we go to the get the grades function. Here, with this function, we can get the nodes in a modular way. Void get the grades, integer pointer array, this is our array, integer initial 0, integer number limit. Now, we create an integer variable to make it a counter, integer I and semicolon. We want the user to enter the grades of the students. Printf, please enter the grades of the students here. And we get the grades with this for loop. For I is equal to initial, semicolon, I is less than initial plus number, semicolon, I plus plus, increase our counter. Scanf the person sign D, address of array I, and semicolon. As you know, we do not have to return anything in a void type function. Also, we do not worry about our array because an array is already a set of addresses. So we do not have to say anything about changes on it to our main function. Okay, our main function knows this array, because an array is already a set of addresses. Okay, now we are here. We got the grades shortly before, and now we will calculate our overall. Overall is equal to overall calculator, student grade array first, and our limit value. These are our parameters, and the semicolon. Now here, overall calculator, it's type float because our overall may be equal to a float number. Integer pointer array, integer limit. We create two integer variables, I for counter, sum for total of the grades. Integer I and sum is equal to 0 and semicolon. We add the grades and find the total. For I is equal to 0, semicolon, I is less than limit, semicolon, and I plus plus increase our counter. Sum is equal to sum plus reference, the parentheses, array plus I and semicolon. We return the overall. We use the type transformation because our sum and our limit have different data types. Okay, they are completely different. Sum is an integer and limit as an integer, but we return to our main function a float number. So the parentheses float our operation here. We return the overall. We return the overall and semicolon. Okay. We got the overall of the grades. We print the overall on the screen. Printf overall, the person sign F, and overall and semicolon. Now we want to see our array's last form. So I will use a function to see our array on the screen. Show the list, student grade array first, and limit and semicolon. Show the list function. Here we print our array on the screen. We can print a lot of array with this function without writing these codes again and again. Okay, we create an integer variable to make it a counter, integer I and semicolon. We print our array on the screen here. For I is equal to 0, I is less than limit, and I plus plus. Printf the person sign D, I plus 1. This person sign D represents I plus 1. Its index actually, and the person sign D represents array I. This is our element. And printf the inverse slash n and semicolon. Now we print our list, our grade list, and here we are here now. We ask the user how many students he or she wants to add. Now execute, compile, and run. I show this to you. Please enter the student number that you will enter their grades. I will enter here 5. Please enter the grades of the students. 1, 2, 3, 4, 5, for example. And overall is equal to 3 now. And our list, the first one, 1, the second one, 2, the third one, 3, the fourth one, 4, and the fifth one is 5th. Please enter how many students you want to add your list. We are here now in our program. We are here. Please enter how many students you want to add your list. Scanf the person sign D and ampersand addition. Okay, that is why I write this function like that. Here, initial and number, because our user wants to add some students its array. Okay, and we will learn a new function now, realloc, to expand our array without allocating extra space for a new array. In this situation, like that, please enter how many students you want to add your list. Okay, if we use reallog to expand our array, address holder array name is equal to reallog old array. This is our first array. Okay, this is our first array. So student grade array first here, like that. And we put these addresses into here, student grade array second. Okay, that is why I define this address holder above. Okay, after that, limit plus extra students times size of data type and semicolon. Here, in our code, student grade array second is equal to reallog student grade array first, a comma, limit plus addition times size of integer and semicolon. Okay, we learned how to use the reallog function and we apply this method to our array. Student grade array second is equal to expand student grade array first, limit, and addition. Here we go to the expand function. As you can see, integer pointer. That is why we returns a set of addresses to our main function. So integer pointer, expand, and integer pointer array, integer limit, and integer addition. This is our area expansion function, expand. Okay, we create a temporary address holder for our array. Again, integer pointer allocated array, and allocated array is equal to reallog array, so students grade array first. This is our array, and limit plus addition, and times size of integer and semicolon. Now we returns the space and the field part of our array to our main function. That is why we use integer pointer for our function type. Okay, this is the important part. We expand our grade array and we put the empty set of addresses and the field part of the array. Okay, this is our old data. Okay, it is not removed. We expand our grade array and we put the empty set of addresses and the field part of the array inside our temporary address holder. So we returns the space and the field part of our array to our main function. Now return allocated arrays and semicolon. Now we are here. We are here now. We expanded our array successfully. I will enter here 5 again. And now, please enter the grades of the students. I will enter here 6, 7, 8, 9, and 10. As you can see, new overall 5.5, and as you can see, our new list 10 students, but in our first list 5 students. We expanded our array here, as you can see, with the reallog function. Okay, when we use reallog, an occupied memory can be allocated by an error. We use this decision mechanism to control it. Okay, if student grade array second is equal to null, printf error, we could not expand your array, please try again, exit 0. If there is no problem, we can continue to add the new students our expanded array as get the grades, but we send student grade array second this time, and we do the same operations here. Here, get the grades function, overall function, and show the list function. And okay, we find the new overall with our overall calculator function. As you can see, we send again student grade array second, and we send limit plus addition as a limit value, okay? We send limit plus addition as a limit value because our limit has changed above. We print our new overall on the screen, new overall the person sign F, overall. We print our new list, show the list, student grade array second, and limit plus addition again, as you can see. This part is very important in order to avoid memory leaks, that is, to prevent the memory from storing garbage values. We release the arrays we have created, okay? This is a new part. For this, we use the free function. Free student grade array first and semicolon, free student grade array second and semicolon. In order to avoid memory leaks, that is, to prevent the memory from storing garbage values, we release the arrays we have created. This is so important. And we finish our program here, return 0. At this part, not here, here. At this part, we do these operations, okay? So I do not want to show this again because you saw these operations above here. And we finish our program here. As you can see, we have 4 functions for the memory allocation. Actually, there are some more of them, but I will I explain these important ones at this stage for you. Okay, one of them is free. One of them is free. We use this at the end of our program, and this releases the arrays, and it prevents the memory from storing garbage values. This is so important for these operations. And the second one is reallog. If we want to expand our array or our matrices, we have to use reallog function, and reallog function saves the old data, and it adds our array and extra spaces. And the third one calloc, and the fourth one malloc. Malloc and calloc opens spaces for our arrays and our matrices. I will explain how we can relate what we have learned today to functions for matrices next week. And that is it for this week. This week we learned how to do dynamic memory allocation with the arrays. Next week we will learn how to apply this learning to matrices. Everything we learned today may seem rather complicated to those who are encountering it for the first time. For this reason, I recommend you to truly examine this code that I shared with you and implement it yourself. Thanks for all your support and patience. See you following lecture. Stay tuned.